you see my how do I say this little hand here, or can you not see it? Can you see my little hand here?
Yes, Doctor, clear.
Okay, all right, okay. So I can just show like this, right? Okay, so capacitance is a measure of capacitor ability to store charge. Uh, so storage capacity. Of course, the higher the capacitance, the greater the amount of charge stored on the plate for the same applied voltage. So capacitor storing charge, okay? So capacitor storing charge using this formula, okay? Um, So you can see there's a V there, and obviously it has got something to do with our calculations, or in our for our circuit analysis. We do know that in this class, our main objective is to find either current I, voltage V, or power P. So in this case, you can see V. So there's something there that you can work it out to find V. So C equals to Q over V. C in terms of farad, the capacitance level. Q is coulomb, the charge, okay? And V, the voltage. So if you just rewrite, it becomes Q equals to CV. So it's, if you notice here, it's per coulomb. Okay, so there's a um, how to say, 1 coulomb equals to this 6.242 times 10 to the power of 18 electrons. So if you're given electrons, and then you are asked to find capacitance value, so obviously you have to divide by a number of electrons per coulomb. Okay, so I think this 6.242 times 10 to the power of 18 electrons, it's a constant for each coulomb. I think it's in your calculator, I guess. So if you need to find um, capacitance values, when the questions gives you electrons value, so what you need to do is just simply get the value in terms of coulomb, and you do know that 1 coulomb equals to 6.242, and if you are given 82.4 times 10 to the power of 14 electrons in this example, and you can get your coulomb of charge, and then just simply plug in the value using the formula to get the capacitance value, right? So that's very easy. So if I, how do I, let me see. So I'm sharing again the whiteboard just now. Okay. Okay, so the first, you have to know, right? So this is voltage. This is charge in per coulomb. Okay, this is V, and terbalik. Sorry. This is the charge on coulomb, and this is the capacitance. Okay. So there are, you have to know the capacitance. You have to know the transient. Okay. So transient means time varying. Okay. So this is simple equation that you need to use just now. This equation, yeah, these equations. Okay, the top one, and the third that you need to know is a capacitor. Okay, so with these three things, I think you should be able to understand the whole concept of capacitors. Of course, I'm not going to go into details on the mathematics behind it. At least you know what is capacitor and how it is being used in a circuit, right? Okay, so that's um, as an introduction of capacitor. It is used to, oops, it has been a while since I'm using online, so to store charges, right? So you got to know how to calculate the capacitor's value. Okay, so capacitor's value is for you to use. This is what this is. This is using formula. Oh, it looks like that. I don't like it. Probably this. Okay, using the formula just now. Okay. The most important thing is actually on this part here and on this part here. So let's look at transient. What is transient? So if I share again the textbook. Okay. Yeah. So that's a there's a phases in capacitive network. The transient in capacitive network happen during this charging phase and discharging phase. Okay. So charging phase and discharging phase. So we call this transient period. Okay, this is transient period from time equals to 0 until it has fully charged. Okay, so oops. Right. So transient happen during charging and discharging phase. So one important formula or equation that you have to know is tau equals to um, resistance time capacitance. Okay, so in a network, so let's say in a network of, okay, so so tau, okay, time constant is the time taken for the transient period to happen. Okay, for the for the okay, for the transient. Right. So assuming there's no charge here. So charging. So this is VC. Okay. So this period here is what we call transient period. Okay. So in this case, charging phase. Okay. Discharging, you will have something like that. Okay. So this is tau, right? Normally, it will take 5 tau to reach steady state. So what is steady state? Steady ni apa? Steady ni stabil, right? Stabil. Kan? So stabil tu is actually here. Ni lah, dia dah stabil kan? Dia stabil. No more charging or discharging. So normally, it will take 5 tau here. Okay? 5 tau for it to reach steady state in any um, simple capacitive network, right? So it will take roughly 5 tau for it to reach steady state. And what happened after it reaches steady state? So questions, what happened after reaching steady state? Okay, what happened after reaching steady state? The answer is capacitor becomes open circuit. Okay, capacitor becomes open circuit, which means if I can simplify like this, at t equal to 0, the circuit looks something like this. Okay, so over here, this is initially, it's a how do I say? This is capacitor, capacitor. So assuming that there's a switch here, assuming there's a switch here. So at t equal to 0, the switch close, zop, close. So at that particular moment, the capacitor acting like a short circuit. Okay. which means current here is very high because there's nothing in between here. It's like short circuit, zoop, okay, current zoop. At t equals to greater than 0, okay, but less than 5 tau, what will happen? So this is the switch, okay, and this is capacitor, right? So it's in this particular time, it is called transient period, okay, and in this particular period is this is capacitor, so this is capacitor. It's charging, okay, it's charging. And after that, so at t, five tau, okay, 5 tau. I think the symbol is slightly wrong. It should be tau, right? It's not t, it's tau. So I just put so that you are aware it's tau like this. Okay. So what happened is the circuit will look like this. So this is the switch. Okay. And capacitor becomes, sorry, not short circuit, sorry. It should be what? Capacitor becomes, everyone, everybody, anybody?
Open circuit.
Open circuit. Okay. So this is very important concept that you have to know. Okay. That after certain time period, capacitor will become open circuit. So don't worry when you see a lot of capacitor in a circuit. Okay. Most of the time, it becomes open circuit. So when it becomes open circuit, there's no current flowing through here. For example, okay, for example, if let's say you are given a circuit like this, assuming um, for example, okay, let's say 1 ohm, 1 ohm, 1 ohm, 1 microfarad, this is 10 volt, right? So if let's say the questions ask you what is the voltage, let's say what's voltage here, okay, and if the question asks you after steady state, let's say after steady state, so you know that steady means stable, okay, you know that this equals to more than 5 tau, okay, remember it's stable means it's here, right, more than 5 tau. So what happened here to the capacitor? Capacitor becomes open circuit, right? So in this case, what you need to calculate is very simple. This circuit now becomes only this, because over here is open circuit and you can ignore this resistor here, right? So I'm sure you can calculate what is VR2 here, right? So what's VR2 here, guys? In this case, anybody? Senang je kan? This is 1 ohms, this is 1 ohms, this is 10 volt. So obviously over here is 5 volt. Obviously it divided into two, right? 1 ohm, 1 ohm. So okay, so even though there's a capacitor here, right? Even though there's a capacitor here, but because the calculation is done after steady state, that means the circuit is already stabilized and it is already after 5 tau, 5 time constant, okay, 5 time constant, okay. So therefore, it becomes open circuit. And you normally don't count or calculate this. So that's the main concept of capacitor. Okay, um, that when after steady state, the capacitor becomes open circuit. Okay, just hold on. Right. Any questions so far? So of course, the use of capacitor, I think you can read this. Of course, to store charges, and when you have, in order for you to store charges, you have to charge it, okay, and then you can and therefore capacitor becomes your battery. Okay, so that's pretty standard, the use of capacitor. But the concept that I hope you understand is that apart from this standard use of capacitor, is the transient of the capacitor, and transient is basically during phases of charging and discharging. It is okay before steady state, right? Before steady state. Okay. So and the third that you need to know is, of course, series parallel capacitor and how do you calculate that. So that's again very straightforward. So let me share the textbook. So the whole concept is that, of course, I don't expect you to remember the formula and everything, but I hope you can understand the concept of transient. Okay. The third one is for you to be able to calculate the series and parallel capacitor. Okay, so this is transient response here, right? So let's see, where is the this one, capacitor in series and parallel. And what happened is that you can calculate the total capacitance value for series and parallel resistance, parallel capacitance. It's just terbalik from resistor. Okay, so for example, this series capacitor, these three series capacitor, in order for you to find the total capacitance, it's actually using this value 1 over Ct equals to C1 equals to 1 over C1 plus 1 over C2 plus 1 over C3 and da da da. So coming back to our whiteboard. Hold on, huh? Wow. Okay, so oops. So for capacitance, the equation is similar with parallel resistance, which is 1 over Ct equals to 1 over C1 plus 1 over C2 plus 1 over C3 plus da 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 da. Okay. And similarly, if you have parallel capacitance is equal to resistance, and Ct equals to C1 plus C2 plus C3 plus da da da. Okay, so that's three concepts that I hope everybody can understand, because I'm not gonna go through the details of the mathematical expressions, the instantaneous value using that expressions and so forth. You can have a look at that, but these three are the most important concept that you have to understand. Okay, so if I were to repeat, the first one is about the capacitor itself, and the use is on, of course, to store charge and to discharge, okay? To charge and discharge. So the construction is basically two plate, okay, with positive and negative in between, and you're using this sort of uh, this sort of standard formula for you to get the capacitance value, the voltage value, and the charge per coulomb. Okay. For you to yes. Oh, is it lost? Okay, still there. Right. Okay, that's the second thing that you need to know. And the third one is on the series parallel capacitance calculations, whereby the the equation is very straightforward. If you have series capacitance, how do you calculate series capacitance? Is basically very similar to what you have when you have parallel resistance. Okay, so let's try questions. Okay, I'll write the questions here. Let me try to find a question for you. Hold on a second. Okay, very simple and straightforward. Okay, try this. 200 microfarad. Okay, so farad is the unit. 50 and 10 microfarad. So just simple, what is the total capacitance? Okay, so total capacitance, again, like I said, it's because its series is equivalent to parallel resistance. So it's so what is total capacitance value? Anyone?
8 millifarad.
Not milli, 8 micro, what?
Oh, micro.
Okay, so but it's correct, yeah, it's micro. So very easy. Okay, determine charge on each plate. So the second questions. Um, determine charge in each plate. Plate means capacitor lah. So it's actually very how to say very similar. Oops, sorry. How do I use this? Okay. So charge on each plate is very similar to current. Current. So this is series. So we do know that this series current is the same. Okay. And we can say Q1. Okay. The charge is also the same because it's very similar to current. Okay. So if let's say So the question, let's say, determine charge on each plate. Okay. So it's CV, right? So C. Okay. And I say for for capacitor one, so it's okay. So Q1 in this case is C1. What is C1 in this case? C1 is 200 microfarad. Okay. So this is equals, yes, any, who's talking just now? Okay, so that's very easy. And similarly, you can do for V2 and V3. Right? Any questions so far? So this is series um, capacitive network. Okay. So this, if I can just write it. Okay. So this is, if you go up, this is how you do for the third one here, right? So if I can just, probably I do this one, I just highlight it, okay? Series capacitance. So this is series, okay, let's try for parallel, okay? Parallel. So let's say it's 48 volt. This is C1, C2, C3. This is 800 microfarad. This is 60 microfarad. This is 1200 microfarad. And what is CT? Oops. What is CT and what is QT? Okay, so how do we do this? Total capacitance CT. Okay, this is parallel, so therefore it equivalent to series, right? So hold on a second. Hold on a second. Right. Let's continue. CT. So it parallel capacitance capac equals to series resistance. So in this case, C1 plus C2 plus C3, okay, equals to, okay, and determine the charge on each plate. So Q1, oops, Q1 equals to C1B, right? Which means it times 48 volt equals to microcoulomb. So as simple as that, just using the value. Okay. So Q2 equal to C2V 60 equals to, okay, millicoulomb, and similarly Q3 equal to C3V equals to times equals to microcoulomb, right? And the total charge just now, oopsie, what's this? I don't know where there's oh, ni kat mana ni tadi ni? Never mind. Oh, here, all right, okay. Okay, so total this is total charge, okay? So it's 38.4 plus 2.88 plus 57.6 equals to microcoulomb, right? So that series and parallel capacitive network, okay? Right. So another thing that I mentioned just now is the transient period, right? So again, transient period, because you already understand the concept of transient period. Okay. Oops. I'm sorry. Where is it? Okay, transient period. So like I said just now, let's say you have 24 volt, R1 equals to 4 ohms, R2 equals to 8 ohms, and you have capacitor there. Okay, capacitor with a value of 20 microfarad, and voltage C, and you have Q1 here. So the question asks, find the voltage across and the charge on capacitor C1 after it has charged to its final value. Or so as per what we understand, this means times equal to 5 tau, which means it has reached steady state, which means open circuit. Okay, which means capacitor has turned into open circuit. Okay, so which means now the circuit becomes what? It becomes like this only. Okay, so 4 ohm, 8 ohm. The question asks what is VC? This is 24 volt. Anyone, what is VC? So VC is actually voltage across what? So VC is actually voltage across capacitor that has become open circuit, but because it's parallel with 8 ohm, so essentially it's voltage here. Okay, and how do we do this? It's just again VDR, right? So how do we do VDR here, guys? Anyone? RT kat atas kat bawah?
RT kat bawah.
Huh? Betul? Let's try. So bawah berapa? What's the value?
12,
Huh?
12. Okay.
Okay, correct.
Bukan.
Correct. So this is 16. Okay, so VC is actually 16 volt, right? And the questions later ask you, so this one done. It asks you what is the charge on capacitor C1. So it's easy. Charge C1 equals to C1 VC lah. So C1 already given, VC you have already calculated. So it's straightforward. Okay, so C in this case is 20 microfarad times 16 volt equals to 320 microcoulomb. Okay, okay? Dapat tak? So that's those are let me just repeat. I think we shall stop in a few minutes time. So that's the whole concept of capacitor that you have to know. I'm not sure. Can I share this with you? How do I share this? Okay, let me see. Later I'll try if I can share it in the WhatsApp group. Okay, so if I can just repeat. Okay. So we have capacitor and inductor that we need to know. So tonight we cover capacitor. Okay, we cover capacitor, and tomorrow, inshallah, tomorrow hopefully same time, probably 1 hour, just 1 hour, 8:30 until 9:30, we'll cover inductor as well. Okay, so there are three main things that you need to know for capacitor. The first one is, of course, the definition of capacitor is for it to store charges. So they're having two phases, which are charging and discharging phases. Discharging, that means if you remove your battery, capacitor will replace the battery supplying the current, okay, because it can store the charge. So there are three main things that you need to remember. The first one is to calculate the capacitance value, of course, very simple, using this QCV, right? And you have to know the transient, the time varying. So what is transient? Is transient before it reaches steady state, okay, during charging and discharging process. So that's what we call transient. And you have to know how to calculate the series parallel capacitance. So transient contains two different phases, charging and discharging. And normally it relates with T equals to RC. So yeah, okay, so and this is tau, so resistance times capacitance, right? So this is steady state period where normally it's after 5 tau to reach steady state, stable. So this is charging and then it reaches steady state. Okay. So what happened after reaching steady state? So capacitor becomes open circuit. So this is very important for you to know that it becomes open circuit. Okay, and the rest of the analysis becomes simpler once you know that capacitor becomes open circuit. Okay, so initially when t equals to zero, when you just switch on the circuit, it becomes short circuit temporarily, okay, and I is very high during the initial stage, but after that, during transient period, it starts to charging or discharging. So in this case, it's charging. It becomes normal capacitor. So once it reaches its final value, that means once after it reaches more than 5 tau, capacitor becomes open circuit and you can just calculate it. Okay. So why then do we have capacitor? Finally, why then do we have capacitor in a circuit? If you know that, after a while it becomes open circuit, like it's got no use, right? It seems. Um, Apart from charging and replacing battery, um, why do we have why do we have why do we have capacitor? Is because normally in a complex circuit, in real circuit, so let's say this is load, this is load. Load can be your television, radio, laptop, etc. Okay, and this is your supply, and this is your total resistance. Okay, in your wiring, and normally capacitor, it is connected. Normally, I say normally, is connected to ground. Okay, because it helps to remember, at t equals to close to 0, it becomes short circuit, right? And therefore all current will be high. So in this case, at the start of, let's say you start off or you turn on your TV, huge current will flow to the ground, okay, because it's being short circuit, and therefore it protects the circuit. And after a few while, after it has stabilized, it becomes what? It becomes open circuit, and therefore it's no longer used, and current can flow as normal like this. Okay, so that's why sometimes you see capacitor as a protection for the circuit. That's why it is used in the circuit. Okay, so I think that's it for tonight. Can we continue tomorrow night for another hour for us to finish off with inductor, guys? Is it okay?
Okay.
Okay,
Can.
Doctor.
All
Yeah,
right, all
Doctor.
right. So,
Can, doctor.
at first I thought I want to finish everything tonight, but I think it's enough for tonight. Um, at least we covered the main things for capacitor. Okay, so tomorrow, inshallah, we'll cover inductor as well. Oh, this one is not being recorded, isn't it? Is it being recorded? Oh, it's not being recorded. Never mind. Um, can I share this? Uh, okay. All right. I think that's it for today. Thank you very much. If you have any questions, you can ask me later. Hopefully tomorrow everybody will be here as well, because we will, after we finish of the inductor, I'll give some tips for the final exams. Okay, for the preparation for the final exams. So with that, thank you very much, guys. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, Doctor.
Waalaikumsalam.